Hi, my name is Eduardo Rox. I'm the author of an Emacs package called EV. Its homepage is here. And this video is about this thing here that plays a series of keys spaced in time, like a pianola. Like here, if I execute this thing here with meta-e, it waits a bit, then it simulates that the user is typing return, then return again, then hello. Let me demonstrate it. That's it. Let me undo this thing. And this thing is not very interesting in itself, but the implementation is very interesting, and the video is going to be about it. Now let me make a longer introduction. EV is a very obscure Emacs package that treats Emacs in a very weird way. I mean, it treats Emacs not as an editor, but as something that started as a Lisp environment and then it became an editor. So the best way to start learning Emacs is by starting by learning the basics of Lisp. The tutorial of EV starts by this. It starts by explaining how these expressions work, and then it shows how to use Lisp expressions as hyperlinks, and then it explains that some things like this one work like hyperlinks, but not really hyperlinks that go to somewhere else. They work like browser buttons that perform an action. For example, if I execute this thing here, it acts as if the user had pressed a series of keys, like this. I can run it several times, and I can undo its output. Anyway, let me go back. And so this is one of the first things that appears in the tutorial. This is a variant that does exactly the same thing, but is implemented in a different way. And this thing here is based on this new implementation. I said that these two expressions here do the same thing, but they do it in different ways. The first thing that this function here, eek2, does is that it receives an argument, and if that argument is a string, it converts that argument to a list of events. The conversion is done by this function here, and when this function here receives this string, it returns this series of events here. Note that each event is a pair. The t is not important now, but the rest of the event is, in this case, the rest of the event is always a number. So the ret becomes 13, the uppercase h becomes a 72, etc. And this function here, eek2, can receive either a string or a series of events in this internal format. And in most of my examples, I'm going to use this representation here, in which the events are numbers, instead of this representation here, in which the events are written in a way that is more readable for humans. For example, this thing here is sort of clearly a return. This thing here is clearly an uppercase h, and so on. Let's test. This thing here inserts a hello, and this thing here also inserts a hello. And note that I can split this series of events into a series of calls to eek2. So this program here is going to do the same thing as this thing here. Let me try. Ta-da! This is a copy of the expression in the previous slide. And let's now change it to something that uses timers. This first expression here runs this, but sorry, it makes this small program here be executed in some time in the future. Then this second run at time does the same thing for this small program here, and so on. And so the first expression, the first eek2 is run at this position in time, the second one is run at this position, thus the other one is run at this position, and so on. Let's test. And this last expression here does the same thing, but it's written in a much more compact form. Let's test. Now let's see how this expression generates this prog-n here. This prog-n here does exactly the same thing as this thing. It plays a series of keys spaced in time. Let's test. And by the way, one of my favorite ways of explaining EEV to people is in this page here. It is here in the section taking apart, and it is this sentence. EEV is more like a toy that is slightly interesting if you play with it for a few seconds, and much more interesting if you open it and take its pieces apart to see how everything works. So this is something that is not very useful yet, but the implementation is very interesting, so let's take everything apart. I will need to shrink the font a bit. Here is the source code. I'm interested in this part here of the source code that explains a big macro. Let me scroll it here to center it on the screen. That's it. These kinds of macros, my let star macros, they are explained here in this section of a tutorial, but the explanation is very technical. Note that it uses CL loop at a few points. Beginners with Lisp probably have never seen CL loop, so if they want to learn it, I added a section about CL loop in one of my tutorials. It is here. It has lots of examples. And let me explain what this macro does. It expects three arguments here that are usually a number, another number, and a string, and then some code. And what it does is that it generates a big let star here, and it runs the code in the context in which not only these three variables are defined, t0, dt, and str, but also these other things here are defined. Let me show how this works. Let's see. Let's try this thing here. When I run this, t0 is going to be 0.25, dt is going to be 0.5, and str is going to be read hello. And the code is just tvents. And tvents is this thing here. The code is going to be tvents, so the code is going to return the value of the variable tvents that is defined here. Let's try. This line here shows that the value of tvents is this sequence of pairs made of a t and an event. This thing here does something similar, but pip purchase is something that starts with a prog-n, and then it has a series of purchases. Let's see. Well, I think of these things as purchase, but whatever. And this thing here generates this thing here that starts with a prog-n, and then it's a series of run at times. I abbreviated run at time as RAT, so RATs is run at times. This thing here is going to show the length of the variable tvents. Tvents is a list, and this shows the length of that list. This thing here is a trick for pretty printing the value of pip purchase. If I run this, it creates a temporary buffer with pip purchase pretty printed in a certain way. Pip purchase is here, is a prog-n with a series of purchase. And this temporary buffer is read-write. I can, for example, I can test this thing here by typing meta e, and it runs a return, and then it types hello immediately. It doesn't wait. And if I run this, it also creates a temporary buffer, but now with a prog_n and a series of run at times. And if I test this, I get this. The prog_n simply creates a series of timers that, well, Emacs stores those timers and run those timers at the right time. So the prog_n returns immediately. You can see the result here. Take a look here. It's going to disappear very quickly. And then Emacs executes this thing, the little programs that are stored in the timers. So these things here give us ways to explore all these temporary variables here. And remember that the value of parets is a list made of a prog_n and a series of run at times, this one here. And if instead of displaying parets with a pretty printer, I eval parets, I execute this prog_n here instead of executing the prog_n in the temporary buffer. Let's try. 1, 2, 3, go. And this is a demo of something that I'm going to show later. That is what happens when instead of giving a string to, instead of sending a string to the variable str, we send a nil. And spoiler, when str is nil, then this thing is executed here. It calculates a certain distance, and then it calculates a number of f8s, and it generates a string made of a series of f8s. Let's see. Distance is 12, and f8 is 11, and f8 is this thing here. Now let's go down a bit. No, sorry, let's go up first. This is the beginning of this file. It first defines the macro here, then it defines the function EKS that plays a series of keys spaced in time, and then it had some tests here. Let me scroll down. Here is the definition of EKS. It says that it's like EK and EK2, but it plays the events spaced in time, blah, blah, blah. And the definition is just this thing here. It calls the big macro above with a certain value for t0, certain value for dt, and then the str as usually a string holding a series of keys. And then it simply runs eval parets here, exactly like in this demonstration here. Sorry. Sorry. Remember that the value of parets is here, and if we eval parets, we get this. So it has this eval parets here, and it has this thing here that gives a better return value. Let's test it here. Let me make everything start a bit later so that we can watch the return. We can see the return value here. Let's try. It says 6 events, and then it runs the events. So that's it. I mentioned that when we don't give a string to EKS, it does something special. It calculates a certain distance, it calculates a certain number of f8s, and it plays this series of f8s. This is Anyway, no, sorry, I'm not going to explain why this is useful to me. I'm just going to demonstrate it. Let's create the shell block, test block here. Sorry, I need a smaller font. Sorry, let me use a very small font here. Let me create a target buffer running a shell here. And then this is a comment because it starts with 2 red lines and it says type F8 on the line below and wait. Let's do that. F8 here. It generates a series of F8s spaced in time, and it presses between quotes this F8s and it executes this thing here. So instead of usually I have to press all the F8s, but in certain occasions I want to make the computer press this F8 itself like a pianola in a certain rhythm, and this is what this thing does. Let's try it again. Oops. If I execute this here with F8, sorry, whatever. And that's it. Please do try this at home. The instructions are in this page here. This page is going to have all the instructions, the subtitles of the video, etc. And the easiest way to try the code without downloading anything, of course I'm supposing that you have Eevee, but the easiest way is to just execute this exp that is in that page. It downloads a local copy, no, sorry, it downloads this page here, this Lisp file here to temporary buffer, and then you can execute it with just eval buffer, and then you can try all these tests here. And that's it. Thanks. Actually, thanks for your attention, and thanks to Bruno Macedo, because many things in this video were inspired by our conversations. That's it. Bye.